Now that we've got some of the basic algebra of trigonometric expressions under our belt, we know how to multiply, divide, add, subtract, factor. We know how to do all that basic algebra stuff with trig. It's time to start getting into identities. And what identities are is they're basically little formulas that you can use when it's useful to simplify trigonometry. So you see, I've written some of the trig identities over here on the right. We've got the reciprocal identities and the quotient identities. And you're probably looking at these like, well, I already knew these. These are the basic ones. These are just the definitions of secant and cotangent, and so on. And that's true, but I want to keep referring to them as identities because these back up some of the reasoning in what we're going to do in this problem and later on in our proofs of trigonometric identities. So let's start with number one here, cosecant times cotangent. What I want you to do, anytime you see cosecants, cotangents, or basically anything that's not a sine or a cosine, I want you to switch it into sines and cosines. And we use the reciprocal identities and the quotient identities to do that. So, for example, cosecant. I know that's just 1 over sine, okay, according to my reciprocal identity. And cotangent, I know that's just cosine over sine. So what's the result of this? Well, I'm going to write it as a single fraction, right? Single reduced fraction with only sine and cosines in the answer. And the result is just a cosine on top, and it looks like we've got a sine squared on the bottom, okay? Moving on to number two. Let's see, what do we have here? Secant squared minus tangent squared. So when I see secant, I think, oh, that's just 1 over cosine. And because it's secant squared, it's really 1 over cosine squared. And that's going to be minus tangent. Well, by the quotient identity over here, tangent is sine over cosine. So I have sine over cosine. And this is something I can almost do right now. It's just that the denominator on the right needs a little bit of work. You can see I need to multiply this by cosine over cosine. A crazy one, so that now I have equal denominators. And this is now going to be all one fraction over cosine squared. And on the top, I just have 1 minus sine omega cosine omega. All right, so that's our answer for number 2. Number 3, last one. Now this one's a little more complicated because it has cotangent and tangent within a fraction, and likewise for cotangent and cosecant. And you remember, all of these things are fractions themselves when we make the substitution to sines and cosines. So it's going to get a little bit messy at first, but it's really not that bad once you get into it. Cotangent squared, well, that's just cosine squared over sine squared, and that was divided by tangent squared. So let's see, that's divided by sine squared omega over cosine squared omega. And we're subtracting, let's see, cotangent is cosine over sine, and cosecant is, I think that's 1 over sine, right? There we go. Okay, so I've changed all my trig functions to either sines or cosines in the appropriate way. And now all we have to do is simplify this mess. So if you think about how to do that, you could use crazy ones to clear the denominators. That's my preferred technique. Even though there may sometimes be a simpler way forward, I would prefer to just do this by clearing the denominators, just so we're consistent. And I'm going to multiply this thing by sine squared cosine squared. Sorry, I'm dropping out the omega. It's just a little annoying to keep writing that thing, and I'm a little cramped for space anyway. So I'm going to multiply the fraction on the left by this crazy one, and the fraction on the right, it looks like that's very easy. I just need to multiply that by a sine omega over a sine omega. Okay, so let's see where that takes us. The fraction on the right I will do first because that is simpler to deal with. I take this sine, I multiply by cosine over sine. You see that the sines are going to cancel out, and all we have left is just a cosine omega. And on the bottom, sine cancels out with 1 over sine. We just have 1. Okay, and then on the left side, well, sine squared cancels out with sine squared, and you have cosine to the 4th. see if I can write what I'm saying. Cosine to the fourth omega. Okay, and let me get rid of that stuff so we can see what's happening. And on the bottom, cosine squareds cancel out, so we have sine to the fourth. Okay, and don't forget the minus sign. So I want this all in one fraction, and this is great progress, but I don't have common denominators. It looks like I'm going to need to multiply this fraction on the right by a sine to the fourth over sine to the fourth, and then I can write everything over sine to the fourth omega. And what do we have? We have cosine to the fourth from the left fraction minus sine to the fourth omega cosine omega. And you might be wondering why I keep writing the sines before the cosines. There's no real reason to that. I just prefer to have the sines on the left, cosines on the right. But it's not like it's any different if I said cosine times sine to the fourth. Okay, there's your answer.